Okay, here we go. Review for the area and pre-solids test. So let's get this thing started. All right, so if you want to find P, capital P, which is perimeter of the base, and if you want to find B, area of the base, then let's look at this prism to do so. Okay, so the perimeter is 2, 8, 2, and 8. So you add them all up and you get 20 for the perimeter of the base. This is the base of this prism. All right, area of the base is going to be the area of the base formula for a rectangle. So it's base times height. 2 times 8 is 16, right? So perimeter and area of the base. All right, what is the height? Well, from base to base, it's 12. You'll use that in formulas. Okay, circumference of the base. Okay, this base of this cylinder is a circle. Okay, so circumference formula is 2 pi r. So you're going to take 2 pi r and plug in the 6 because that's the radius, right? 2 times 6 is 12 pi. 12 pi is a good answer. Okay, big B, area of the base. Okay, the base in a cylinder is a circle. Area formula for a circle is pi r squared. So the radius is 6, so we take the 6 and plug it in here. 6 squared is 36 pi. So the area of the base is 36 pi. Okay, circle formulas. All right, there they are, circumference and area. Okay, arc length is the actual length of this red part of the circumference, right? Arc length is a length. It's not a degree measure, it's a length. Okay, but you use the circumference to figure it out. So we have our degree fraction. That's how much of the circle that I want to measure. Okay, I want to measure 60 degrees out of 360. Okay, I want to know if I reduce that, it's 1/6. Okay, 1/6 of the circumference. Okay, so I bring the circumference down here, obviously, and then I just 60 divided by 360 times 2 pi r. Okay, and the r is 4, right? So that'd be 8 pi. Now sector area is finding the area of the piece of pizza. Okay, so the only thing different about this, we still have a degree fraction. We're just going to use the area formula instead because we're getting a part of the whole area of the circle. Okay, so here's the degree fraction. We want 60 out of 360 degrees of the area of this circle. Okay, so this red portion here is this much of the circle, and you multiply it by the area of the whole circle. So 1/6 of the area of the whole circle, you plug the 4 in there, and you get the answer. So here's an arc length problem. So we do 135 out of 360, right? Okay, 135 out of 360, and then we want to know what that's the portion of the circumference, right? So the circumference is 2 pi r. The r is 4, so I plug the 4 in there, right? So 2 pi 4 is 8 pi. Okay, so I take this and I divide by 360, and then I hit enter on my calculator, and then I multiply by 8 pi. Okay, and that gives me a length of 9.4. So it's 9.4 from A to B in inches. Okay, not degrees. Okay, area of the shaded region. Okay, area of the shaded region. So our degree fraction is 45 out of 360, right? So 45 out of 360, and then we need, that's the portion of the area that we're going to do. So we use the area formula, pi r squared. You take 8, plug it in here. 8 squared is 64 pi, right? And then so divide, hit enter, and multiply by 64 pi, and you get 25.1, which is the area of this piece of pizza, all right? Okay, triangles and area. If you have a triangle that's a right triangle, then you've got a base and a height built in, right? So area of a right triangle is base times height divided by 2, right? So it'd be 6 times 8 divided by 2, which is 24. Okay, if you have an equilateral triangle, then you need to put a height in there because you have to have base times height. You know the base is 12, right? Okay, so this is a 30, 60, 90, right? So since it's a 30, 60, 90, you divide by 2, and then you multiply by radical 3. Okay, so this is 6 radical 3 for the height. The base is 12, so we do base times height divided by 2, right? So you put them in there. All the outside numbers work together. 12 times 6 is 72, divided by 2 is 36, radical 3. 36 radical 3, if you punch it into the calculator, will give you 62.4. Okay. All right, composite area. We need a plan. Here's our plan. We're going to do the area of half a circle, area of a square, plus the area of a triangle. Okay, so half a circle would be pi r squared over 2, right? Base times height for a square, and then for a triangle, base times height divided by 2, right? So we have to find the height. We know what the base is. The base is 8. Okay, so I'm going to do this. I'm going to do the half a circle first. So the radius has to be 4 because 8 is the length of a side, right, of the square. So that would be 4 for the radius. So plug it in there. So 4 squared is 16 over 2, which is 8 pi. Okay, and base times height of the square is simple. 8 times 8, right, which is 64. And then base times height divided by 2 for this triangle. I need the height, right? Because I know what the base is. The base is 8. Okay, so this is 8. This is 4 divided by 2, and then you multiply by radical 3. So 4 radical 3 is the height. Okay, so base is 8. Height is 4 radical 3. 8 times 4 is 32. Divided by 2 is 16 radical 3. Okay, 16 radical 3. And then you just put it all into a calculator and 116.8. Okay? All right, squares and area. So you have to figure out the length of these two parts, right? I mean, a square, you just length times width, right? Same number times same number, right? If it's 2, then 2 times 2 is 4 for the area. So we just have to figure out what the length of one side is and then multiply it by itself, right? Okay, so this is a 2 by 2, right? So the length of one side is up 2 and over 2. So we use this. Square root of 2 squared plus 2 squared, the adding Pythagorean theorem, and that gives me 2 radical 2, or 2.82 if you want to round it. Okay, so the length of one side is 2.82. So if it's a square, all the sides are 2.82. Okay, so the square is base times height, so 2.82 times 2.82 is approximately 8. If I'd have multiplied this, it would have given me exactly 8. Okay, all right. When do I use the apothem times perimeter divided by 2 formula? Well, with regular polygons. Regular polygons. Remember, regular means that the sides and the angles are all congruent, like a square or an equilateral triangle. And of course, we always talk about the regular hexagon too. So here's the shapes. Okay, this one is the 30, 60, 90 laying down, right? Okay, so that's the 30, 60, 90 laying down. Okay, this one is the 45, 45, 90. And then this one is the 30, 60, 90 that's standing up. Okay, so the apothem is the one that's straight down, right? Straight down. And then the radius is the one that's diagonal. Remember that? Okay, so if I need to get the area, then I need to find the apothem and the perimeter, multiply them together and divide by 2, right? Okay, so here we go. Let's say we've got the stand-up 30, 60, 90 because we're trying to find the regular hexagon. Okay, they give us 20 for the side, right? So there's 20. This has got to be 10, right? And then multiply by radical 3, right? So isn't that 10 radical 3? So that's the apothem. Now I need the perimeter, right? Okay, so 10 is half a side, so the whole side is 20. 20 times 6 sides is 120, right? So I get 120 there, and then I take these two and multiply them together and divide by 2, right? Because I use this formula. So 10 radical 3, right, is the apothem times the perimeter divided by 2. So 10 times 120 is 1200, divided by 2 is 600, so it's 600 radical 3. And I think, yeah, I did it this way, or it could be a decimal of some kind. 600 times 1.7. Okay. All right, here's a shaded region problem, okay? So if we want to do the shaded region only, then we have to take a circle and then subtract. We have to, well, 6 radical 2. We have to subtract the square away from it, and that'll leave the shaded part, right? Okay, so the area of a circle formula is pi r squared, right? And then the area of a square is base times height. Okay, so if I can figure out the length, I can use the apothem times perimeter divided by 2 formula, but why if I can figure out the outside and do length times width, right? Same number times same number. Okay, so this is a 45, 45, 90, right? So if I want these two sides right here, which are going to be the same, I divide this by radical 2, okay? And you'll get, the radical 2's cancel and you get 6 and 6, right? So then, uh, let's see, we're going to plug in the radius, which was this one right here, right? Which is 6 radical 2. We plug it in here and we square it, okay? 6 squared is 36. The square root of 2 squared is 2. So 36 times 2 is 72 pi. Okay? So I have 72 pi here. And then if I want to know what the area of the square is, I could find the apothem. I mean, I've got the apothem and I could do the perimeter and all that and divide by 2. But, you know, one side is 12, right? The other side is 12. So 12 times 12 is 144. So 72 pi minus 144 is 82.2. Easy? All right. Working backwards. So if they give you the circumference, what's the diameter? Okay. There's a circumference formula. Look on the formula chart at the top, and there's a formula that has pi d in it. Okay. We're trying to find the diameter, right? They give us the circumference, so you plug it in for c, right? And then to get diameter by itself, you have to divide by pi, right? So you divide by pi, and this divided by this will give you 12 for the diameter. Easy? Okay, let's work backwards in an area problem. Okay, if the area of a pizza was 804.2, what is the radius of the pizza? Okay, area equals pi r squared. Just be careful. If they ask for diameter, you're going to have to multiply the radius by 2 at the end, but they didn't ask for diameter. They asked for radius. So here we go. So we want the r. So we plug in the 804.2 for the area, and then we divide away the pi, right? And then we've got r squared, after we divide this, is equal to 256. Well, remember you do the square root of both sides, right? And the square root of 256 is 16. I know that 16 times 16 is 256, right? So r is 16. If that asked for a diameter, you'd say it's 32. Okay, well, y'all have a great day. Let me kill this thing. Bye. Bye.